So let's start. By a show of hands, how many of you are into medical devices or planning to do security assessments for medical devices? Very cool. One, two. Very cool. So this talk will be helpful for you for anyone actually to start pen testing medical devices, hospital networks, anything that you need is over here. You can refer to these presentations. I'll be sharing a tool so you can use that. If there's any bug associated with the tool, just mail me and I'll fix it. I'm pretty active on email. I'm not that active on social media. And the hospital security project is currently down because I don't have time to maintain it. Sorry for that. But I have a Twitter handle. If anybody would like to work with me on hospital security project, just reach out to me and I'll give you access, or we can publish research. Right now I'm also working on honeypots, so I plan to publish the honeypots in probably during DEF CON. So you can use them for your own research, for playing around with medical devices, the way a medical infrastructure would behave. So that's it.
If you'll take me to DEF CON, I'm in.
Oh yeah. I mean, if you want to publish a paper with me, it's fine. Like, just reach out to me. I'm cool. Okay, so let me start with who am I. I am a graduate student at Northeastern University, Boston. I code occasionally. Most of that time is just for getting hackathons or probably writing some dirty scripts to break into systems. I am an active member of Null and Sysinfo. I spoke at Black Hat recently on the same topic. I have spoken at Russia, Taiwan, and this is my second time presenting at NullCon. I usually speak at other conferences. Like if you want me to speak at conferences, just let me know. And I used to work with Philips Healthcare, and I used to work with Infosys Limited. At Philips Healthcare, my job was to break into medical devices, infrastructure, anything that is associated with healthcare. So we did a lot of protocols, we did a lot of IoT devices, and there are positions open in Philips, so just check them out. I also maintain this handle called Secure Hospital. So this is just for spreading news about healthcare and the kind of hacks going on. So any interesting news that I find, I usually share it over there. If again, this is all of these are not actively handled because of time constraints. Let's talk of the agenda today. We're going to talk about security inside of hospitals. We're going to talk about HL7 2.x, and why are we talking of HL7 2.x? Because almost every device in the world works on this protocol. All the big companies work on this protocol. We'll understand the protocol, we'll understand the messages, and then we'll try to understand how do you take down hospitals or medical devices using this. How would you potentially do a DOS attack over the whole system, take down devices? And we'll talk of defending these against these attacks, and then we'll talk of FHIR, which is the next generation of interoperability standards and the changing threats. Right, so let's start. So if you look at hospitals, there are three ways, or this is the way I see hospitals and their security. One is patient monitors. So you have devices which are obviously patient monitors, MRI, ultrasound. Then you have networks that you can attack inside of hospital, and then you have protocols. So these protocols are used by medical devices, especially so the DICOM is used for communicating between your imaging systems. So MRI would use DICOM. HL7 actually governs all of this. So it can actually interact with DICOM, it can interact with other systems also. And then you have FHIR, and again you have HTTP and FTP over those systems. The other part of hospitals and attacking them is the EMR systems. And I gave a talk last time on how do you fingerprint EMR systems all around the world. So how do you find patient records using open source intelligence tools. And I was able to find around 20,000 of such instances where you can break in, get the patient records and just move out. So, and they were from everywhere. So from India, US, you name it, it was from everywhere. All right, so let's start. So HL7, this HL7 is basically the biggest interoperability standard in the world today. The reason why they're so popular is because they're really old, and a number of companies and a number of countries has come together to create this protocol. It's actually a standard, and we'll jump on the technical details, but it's the most popular standard, and that is why we're talking of, whenever you talk about hacking medical devices, you always think about these standards, because if we manipulate these standards, you can actually crash those devices. In a nutshell, HL7 is everywhere. So this is the EMR. So the EHR, or electronic health record, is the centralized system which holds all the medical records. So if you go to a patient, if you go to a hospital, if you're admitted to a hospital, this database you will be interacting with this database. Anything that you do out of it, anything that you do in a hospital will be interaction on this. So this guy over here interacts with doctors, your MRI, X-ray machines, patient monitors. Probably when you're lying on an ICU, all the records that are being shown to your doctor are through this guy, right? Everything works on HL7. At least most of it works on HL7. So let's start with understanding what HL7 message looks like. So it's actually what we call something as MLLP. MLLP was a protocol that was designed back in 70s. It's a really simple protocol. So what happens is, this is a TCP IP connection. You can use a raw socket over it. There is a starting block, which is hexadecimal 0B. Then you have a segment called MSH segment, which is the first line. You have an EVN segment, which is the event segment, and you have PID segment. Then you have the end block and carriage return. Now this is really important, because if you are to interact with these systems, this is the format that they accept. Right? So if you send in something else, the system will discard it. Right? And this is where the fun starts. When you are able to understand this structure, how do you manipulate the messages to attack the systems? All right. So this is what you need to know about HL7. This is the most common delimiter. So we'll see HL7 messages right now, but just understand the pipe symbol means it's a delimiter between fields. The caret means space. So the protocol by design does not have the character space. So you use caret. There is MSH segment. This is the first segment. This is an important segment because most of the attacks that I'll be talking of is based on this. And how do you manipulate this? Then you have all of these messages. And these, just look at them. We'll talk about these messages. If you're pen testing a hospital system, this is what you should be looking at. I did not put, there are two more messages onto it. So if you gain access to these messages, you can pretty much own a patient record. You can manipulate the machines to give you unauthorized access to medicines. So if you want medicinal marijuana or some other banned drug, you manipulate the RDE message and you will get access to it. Some of the machines, like some of the countries, have automatic dispensers. So you put in this message and they'll give you medicine out of it. If you manipulate this message, you will be able to get access to non-prescribed drugs. Okay, let's start with the first message. This is the admit, discharge, and transfer message, which is called ADT. Now, just look at this over here. Do not be intimidated. We'll see how to view these messages. Now, this message is responsible for, it contains patient information, the doctor information, patient visits, and allergy details. Now, this message is important because the first, whenever you visit a hospital, this is the message that is generated. So you can register fake patients using this message, replaying this message. The interesting thing is this, the entry points really depend on the connected infrastructure. So, you know, EMR systems are usually web-based systems. So if you're able to manipulate this message, you can do JavaScript attacks, buffer overflow attacks. There have been some systems where we were able to crash systems and they did not recover. And now the vendor is in the process of fixing them. Some of the systems cannot be fixed by design. EMRs are a prime target for this. Let's talk about ORM message. This is a message which is just like ADT, but this message is actually used for placing orders. So if you go to a patient monitoring, like if you go to get an X-ray scan, this is the message that will be generated. So when you see these messages, just try to understand that there is connected infrastructure. So there is an MRI machine if this message is going on. This can be used for fingerprinting other devices. This gives leverage as an attacker to find these devices. What you can do is change the patient information. You can change initial diagnostics, and this is something that is really dangerous. What if I change your allergy segment or your blood group? And this is where these messages come in really important. This is ORU, so let's assume that you are in the ICU. This is the message that is generated. So your pulse records, any of your diagnostics will be sent through this message. What you can do is you can literally harm someone, and this is really important because this can send out false alarms. If you block this message, it'll create more of a panic. It can be harmful for the patient. The potential entry points include the OVX segment, and there was a really cool attack that we did. So HL7 by design, you cannot send a file over the system. What you need to do is send a path. Now, if you change the path over this guy, what happens is it fetches the resource from somewhere else. So you can actually tell it to fetch a resource from outside of the network, and it'll do the same. Right? It sounds scary, but again, you can do a lot with this. Is everyone following me, or? Right? I'm sorry. This is like the boring but really important part, and then we'll see some cool demos on how do you. This is the message that is RDE message. This is when you send in medicines, and it's important. Why? Because you can change the medicine and dosage. It can be used to gain authorized access to unauthorized drugs. You can also attack vending medicine dispensing machines using that. And there was a proof of concept done in Taiwan for this. I don't remember the device. So you can change all of these information. The next one is the medical document management, and this is really important. Why? Because the word over here, so it says the main purpose of the medical record is to produce an accurate, legal, and legible document. So there is some legalities involved in this. And if you gain access to this message, this is like the patient's entire history. So if you were stealing patient records and you were controlling a CNC server inside of a hospital, this is the message that you will exfiltrate. So this is how the message looks like. Again, I do not need to stress much on this. This is the DFT message. The word financial is there. So this is used when you are clearing patient dues or any bills that you have. If you want to just keep your bills to zero, maybe you won't want to just change this message. And this looks like this. Now let's jump on to the fun part, and we'll see how do you view these messages, gain access to HL7 files and dumps, and we'll see how these messages look like. All right. So first of all, let me just start with how do these messages look over So this is a Wireshark trace that you would get inside of a hospital, or this is a network that I'm running on my system. So I created my own lab to test all of this. If you look at this, this is the kind of messages that you would see, and this is a really small trace. If you do it on a hospital network, live hospital network, in 5 minutes you will actually get around 2 GBs of dumps. So it's really important when you're pen testing hospital systems, make sure that you have enough memory and try to target IP addresses one by one. If you try to do a whole dump of the entire network, you will not be able to succeed. We tried this, we put in supercomputers to get access to these systems. It doesn't really work. So I'm targeting one of the systems right now, and this is the kind of trace that you'll see if you get it. So this is what you get. This is actually HL7 messages in. Can everyone see this? No, you need to come in the front. Right. How do you zoom in? I thought the projector would be bigger. Okay, just try and understand that this is some junk data, but the aim is that this is a text protocol. So the same way HTTP operates, this operates the same way, and all of these messages are, in my experience, sent over clear text on plain text over hospital networks. Now this is dangerous and important because if an attacker were to break into a system or just sniff these networks over a Wi-Fi, he will get access to to data like this. Most of these times, these messages go unnoticed for security folks because they don't understand what these messages are. But it's ultimately these messages that matter. So let's look at how do you make sense out of this. So this is a tool. This is called Smart HL7 Viewer. Can everyone see it now? Is it somewhat legible? People in the back, can you guys see this? All right, cool. So these were the traces that we were seeing, right? And it looked a little jumbled up. But if you look at this over here, this guy actually does a really cool job of splitting this and showing this information in a much legible way. So if you see like this, you'll try to understand that this is the sending application, this is the receiving application, this is the type of message that is going on, and then you have PID, which is the patient identifier. This is where information like patient name, date of birth, sex, race, permanent address, phone number, SSN number, marital status, this all goes over the hospital network. And if you use this tool, then it starts to make much more sense because now you can extract data out of it. Anyone has questions till now? All right, cool. So what has happened is we were able to get a Wireshark trace, then we were able to dump in information to this tool, and we were able to extract information. Now this is just one way of attacking systems. There are other ways, other things that you can do with this attack. And let's see, let me pull in one more. So this is the ADT message that we were talking about. So this is how a typical message looks like. All right. When I copy this and I paste it over here, it shows me information again. Right. This is the point that we're trying to make, that it doesn't matter if you're not able to understand that, but if you use tools like this, or if you're trained enough to understand these protocols, you will extract information out of these systems. So, and it's scary that the kind of information that these guys hold. So this is the allergy segment, the AL1 segment, and probably this guy is allergic to aspirin. This is the diagnostic segment, and we'll try and understand that these messages can actually be replayed, and someone can actually change all of this. So this is how you view HL7 messages. There are other ways of creating these messages, and we'll see. All right, let's move to pen testing these messages or these devices. So so what happens when you scan a machine that is running HL7? You get results like this. All right, is everyone able to see this? Okay, oh man, this is bad. Okay, can you see this now? No, okay. Now. Can you see this now? Okay. So what has happened is I've run a Nmap scan over this system, and it says unknown paging services, and it tries to take a guess out of it, and that is where obscurity comes into picture, because we really don't understand that what kind of services are running on the system. What I'll do is I'll show you a scan that actually I did last night. So if you were running a scan using Nmap, so this is a machine that is running HL7 messages. Now the host, the target is 192. Can everyone see this? All right, cool. Okay, so I'm running a scan on 192, 190, 168, 236.2. Keep in mind, in a live systems, you never run intense scan over these systems. Many of these systems can actually crash if you do an intense scan using Nmap. Right? So it's usually a slow progressive scan that you do. Now, what I'll do is I'll run this system. Because I control all of this environment, I know that this guy can actually handle intense scans. When the scan's complete, you get something like this. So this is interesting because this guy shows that there is probably Tor running on a medical device system, and probably there is something called black ice. Right? Why? Because Nmap tries to take an educated guess on the common ports and the services that run on them. So port 9001 probably is used by Tor, and port 8082 is used by black ice. Right? That is where this is where problems arise, because if you're pen testing medical device systems, these systems can run on any port and you can be misled. So to avoid this, I wrote a tool which does all of this and does more. Let's see, let me. Okay. So if you are pen testing these systems, try sending MSH, and it'll reply back, and we'll see. So this is a tool that I wrote. I just named it healthcare HL7 2.x auditor. Now this tool, what it does, it does a recon. What it does, you give it an IP, and it'll scan all the ports, and it'll send messages on MSH, and it'll try to force the machine to send out a message which is an acknowledgement message or a not acknowledgement message, to find out that a port is actually running. So what I do is, can everyone see this? Okay. No? Okay. All right. Now, are you able to see this? Okay, cool. I cannot zoom more because the screen size is small. So I give it an IP address, and it says I can scan the IP for 2.x ports, I can send it ADT messages, or I can send these messages. This is to make an educated guess that, are these ports running? So I say 1, which is, so when I say 1, this guy actually starts to scan the network, and it found port 8082. The reason why I did not show all of this, all of the scans running, and it hitting 8081, 8082, the reason was there were a lot of messages that were being generated, and you have to have a really good, you had to scroll a lot. So all of this is actually logged into a system. There is a log file that is generated, so you can look at the logs and you'll figure out. So it find a port open on 8082. Now it says, do you want to look for other ports, or do you want other options? So I say N. So it says that, do you want to look for message types? Now what it'll do is it'll try to brute force, and it'll try to find out the kind of messages that this port accepts. Now, why are we doing this? Because a single port can actually handle multiple types of messages. So it can take ADT, ORU, all of these messages at one time. And in a later stage, we'll try to understand that we can actually brute force and take down systems like that, because you can fill in the pipeline and the machine will run out of memory. So I say that, let's scan for other message types. So it sent an ADT. So this guy is probably an EMR. We sent an ADT message, we sent an ORU message and ORM message, and it replied back. Right? How do we know that this is a legit reply? Because of this guy over here. It says AA. Every acknowledgement that you get, a positive acknowledgement, will have an AA, or else you'll get a NAC message. Is everyone able to follow this or no? Okay, just let me know if you're not able to follow this. There is so much to talk in just 45 minutes, so I'll have to do it like this. So what it does, it gives you all of these messages. Now I can use this information to attack these systems. So I can fuzz these messages, or I can insert my payloads over it. All right, so all right. So if you get an ADT, this is usually for a registration desk, so probably a nurse desk. An RDA for medicine dispensing machine. In this case, it was an EMR system, so it could take all of these messages and send it to the appropriate places. So if you detect that this message is being sent to this guy, try sending in garbage messages, and you will be probably able to admit rogue patients or get medicines out of it. Let's talk of the common flaws that that HL7 2.x has. The biggest flaw that I feel is there is lack of encryption between the endpoints on hospital systems. So if we talk of a hospital system, let's say a patient monitoring system, and then we talk of an EMR system, I've seen really few hospitals that actually put encryption over it. So some of the hospitals actually have subnets for different machines, but literally what happens is you scan the network and you dump all of this information just like that. And this is a really big flaw, but the bigger flaw is that you can actually do man-in-the-middle attacks. So you can send in, you can take these messages to a man in the middle, and because there's no encryption over it. The reason why this happens is there's lack of support on the hospital side. So the hospital IT systems or IT administrators usually push back and they say that we don't have resources to do that, and it costs money. So vendors, medical device vendors, have an option to give you support for encryption, and they want you to purchase certificates, right? Because it costs money and it costs operations. The hospital IT usually says that we cannot afford that, and this is a big problem. The second is the message source is not validated. So this was interesting because we emulated a system when I was working at Philips. We emulated a system which would accept messages from anywhere, and I could broadcast messages saying that I am a patient monitor, and these are the observation of this patient, and it would accept and update accordingly. There was a big bug with some system that we were testing, not with Philips. It was a third-party system, and it's not been fixed till now. So, good luck. A bigger problem is the unvalidated size. So HL systems 2.x by design does not have size over these messages. So you can what it does is it can break the message into parts. But this is an attack that we'll see. What I can do is I can send it, messages that are bulk in size, and the system will actually crash because it cannot hold much data. Most of these systems run on legacy machines. So you have Windows NT. I've seen this run on Windows NT, Windows XP. Those guys just crash for no reason, I think. So yeah, it could lead to buffer overflow, and we'll see. One of the other flaws that is there is the upload and download functionality. Now, what happens is if you're able to sniff this connection, you can change a field which says, download this file. So if you have an X-ray scan done, it's usually in form of PDF. and the HL message that is 2.x message that is sent is usually a path to that PDF. So if you change that path, you can do an RFI, or you can actually point it to some other system over the internet to download stuff. So instead of a PDF, you can tell it to download an EXE and it'll download it. I cannot show those demos because of obvious reasons. This is a really cool attack that I found. Basically, this can actually disrupt the entire hospital functionality. And we'll see how it happens. So every message, HL7 message that you send over here, requires that you send an acknowledgement message back. So it's usually an ACK message, something like this, right? So every message that you send has this reply. It says MSH AA. If I don't send this message back, the machine will send this message again, right? The same diagnostic message again. Now let's take this into perspective and see how an attack is done. Let's say you are in an ICU and you have a patient monitor attached to you. Every message that it sends, which is an observation, requires an acknowledgement back. If I am an attacker and I block the port, or by a mistake, I disable the acknowledgement on your patient monitor, if not configured properly, will send the same diagnostics again and again. So let's say you had a BP of 98, it'll send 98 every time. And if your blood pressure dropped, the doctor will never know, right? So this is one of the biggest flaws that I found, that you could do this just by disabling one port. So you can take down the entire operation. And the bigger problem is the volume of data that is generated goes into terabytes with flaws like this. So you cannot actually fix this really easy. The other thing that you can actually do is, and this is really funny, you can crash patient monitors just like that. So one is if you do not send acknowledgement, one if you send an acknowledgement just like this. So the patient monitor also parses this. And if you send a string of A's or something like that, the patient monitor can also crash because it cannot handle that much data. This is how a denial of message actually looks like. So you send in ACK, and it just dies. Let me show you a demo on one of these DOS attacks. This is a first crash. So this is an attack mode. And attack mode, what I just do is I send in a large string of A's. So I'm attacking this machine. What I'm doing is I'm just sending A's, a string of A's, and then a string of connections to the same port. I know this port will crash because I've configured it, and this is. I'm sorry. So I say attack mode, and you'll immediately see that the device crashed and I'll get a socket error. The reason why this happened was I sent in a large number of A's that the system on the other side was not able to handle. And this is a flaw that I found with many systems. Most of them do not fix them. But if you take any emulator off the market and you try to do these attacks, they will happen the same way. The other attack that we talked of, let me show you another one. So these systems by design, so this is another DOS attack. So I just configured the EMR to send in just a string of A's, and any system that is connected onto this just receives a lot of A's. Some of these systems actually crashed. There is another DOS attack that I wanted to show you. This is one of my favorite ones. I'm sorry I cannot zoom into this because there are two screens. What is happening over here is I'm sending an ADT message, which is a registration message on this IP over here. What I'll try to do is I'll take that buffer and the number of buffers that it can handle at a point. So one point, and we'll try to create a condition where it becomes a race condition where every thread needs memory, but none of them gets full of it. So what I'll do is I'll spawn multiple systems onto this. So this is a normal response. I send in a message and you get a response. So I sent in a message over here. I got a response. What I'm trying to do is a DOS attack. So this guy over here, this script, actually sends in messages that are big, and at the same time it does not release the thread. So it says that, I'm sending you more messages, just wait, just wait, just wait. And it says yes, because of the size and the other flaws that we talked of. So this is the DOS script that is running. What I do again is I'll send in another request. So if you see over here, it says big payload sent. It was just a big payload, so it's sending in strings of A's and MSH, the field MSH. The reason why this works is because technically this message is correct. It has a proper segment, but the message size is really big. I send in a message again and it works. So I send in another DOS attack. So what happens is I'm taking another thread from its memory, right? I send in again. So right now it's able to handle 2 of them. Right, so I send in an ADT. Now this guy is actually acting strange because it's not getting a response back. Right? So these are 3 threads. This is the 4th thread that I'm starting. This takes in one more resource out of the system. In big systems, in hospital systems, they can typically handle 10 or 15 streams. But if you really want to do it, just pop in 100 and it'll relate into a DOS. So right now I'm not getting a response from anywhere. These systems aren't working, and this was a legit script that I was sending in. This is not giving me any response. So I send in an ADT, and everyone just runs out of memory. So you'll see that the right guy over here will never receive a message after this. Okay, it received a message. This was the maximum memory that this guy had on the left side. And I'll just run out of memory. So this is how you typically do a DOS attack over one of the streams. We were able to demonstrate this attack over one of the third-party resources that we had. We were able to hijack all of their streams, and no other machine could send in message to that because we were just requesting for the particular resource. Okay, let's talk of fuzzing these messages. And why I wanted to talk fuzzing on this, because there are a number of tools in the market which claim to fuzz HL7, but they're not able to fuzz it. And I'll give the reasons why. The first reason is HL7 2.x is an interoperability standard, which means if Philips has has an implementation of HL7 which works for them, it's not necessary that Siemens will use the same configuration. So if you have a payload that works against Philips devices, those might not work against Siemens. So anyone who tells you that we have a fuzzer, try to understand more details on how the fuzzer actually works. Right? Typically what you will do is fuzz fields instead of the whole message. So a simple scenario would be looking at a message like this. Right? Let me just zoom in. Can everyone see this? Can everyone see this? All right. So let's say I want to fuzz the patient segment. I will fuzz this field, and that is all fuzzing that I'll do. And you need to understand that if you're fuzzing this field, you need to understand the impact of this field. So it might be a possibility that you're fuzzing and you're getting no results. The reason is that you're not fuzzing it at the right position. right? So there are very complex systems that run this. So you'd probably write your fuzz over here, and this is what will generate. And this is a reason why most of the vendors who try to fuzz these systems fail, because they would fuzz in the whole field, which will be probably discarded by the software, or they would fuzz the whole message and such, and the system will just discard all of this. So it has to have a legit structure. So it has to have this segment, and then you can fuzz different fields. An example scenario will not talk. So let's talk a little bit about the defense of these systems. Validate message size enforce two-way TLS, which means that each and every device on your system has to know the other system. So if you have a patient monitor, hard code your certificate of the EHR onto that, right? And I cannot stress more about that. I've seen this practice of anonymizing HL7 messages on celebrities. So if this was interesting, and I was talking to a hospital provider, what happens is if you get a celebrity on their systems, they would actually anonymize their names. So their names would not be sent over the network. So they would say patient name or something like this. But that is a really good practice. And I believe if you are a medical device manufacturer, you would like to do this. Have input sanitization, unvalidated file downloads, add a checksum. That is pretty basic. And I've not seen anyone use a checksum on HL7 systems, which is bad. This is really easy to implement. Beyond medical devices, secure a network, understand network devices, follow hospital project. Let me talk of this thing, and I really wanted to catch up on this. FHIR is the newest interoperability standard that will come. Now, this is not equal to HL7 3.0, which is a different protocol altogether, which did not quite kick out. But the interesting thing is, it's more like an HTTP request. These are all JSON requests that go on FHIR. And I'll tell you the problem with what happened when I saw implementation on these systems. What happened was, even though if it was FHIR, people were sending HL7 messages on FHIR. So you had flaws like JSON injection on this system, but then you had flaws that HL7 had on those systems again. Right? So this was a really interesting system. Interestingly, FHIR will be used on systems like your Fitbit or portable machines. I've seen some manufacturers send HL7 messages and inside of FHIR over mobile phones. So probably if you want to enter into this field of medical device security, have your JSON systems or REST API systems really validated and your concepts cleared. FHIR will replace HL7. It's lightweight. Developers are using this, which is not good at all. Okay, questions? I'm sorry. I'm sorry if this talk was really fast, but there is a lot of information, and you can always reach out to me. Just email me.
Hey, hi. It was a good session, but just wanted to understand, in case your team is working on the pacemaker side and defibrillators, I'm like how they are being protected, because what we see right now with the pacemaker, people do the reverse engineering, understand the communication protocol, and then they try to do the modification or sniff it and modify or change the heartbeat or something like that. So
Yes.
any research is happening from your hand side?
So what I've seen, I've not worked on pacemakers, but what I know about pacemakers and what I talked about people was they don't use HL7 over those systems. So it becomes more of general IoT security, where you actually do side channel attacks or probably would do sniffing attacks. That is like a really general thing. It's not exactly healthcare security. So you can do it. Okay. So this is what you need to keep in mind. So it has to have a vertical segment. You can do it using Python. You can just go to my GitHub and I've used it. Feel free to drop a question and I'll tell you. So you just need to have a beginner segment, a vertical segment, and an end segment, and throw anything in between, and it'll accept that. Yes.
I would like to know if there is any kind of an attack on a surgery medical device.
I am not aware of that because there are these include robotics,
Yeah.
and I have not worked on robotics. It will be what I believe it will be more of embedded security, but I have not done any attacks on robots as of now.
Thank you.
Yes. Nice talk. Thank.
So the HL 7.2x, are they going to upgrade anytime near future? Or?
Yes, FHIR is being upgraded.
Okay, when
So,
is
but the standard itself will stay for about 20 years. The reason is because if you talk of life cycle of an X-ray machine on an MRI machine, it's usually a year or two. So if there's a bug, it will be fixed in the next 6 months or a year, and that is why adoption of FHIR is taking time.
So the existing machines
Have this
they,
bug.
Yeah, so I mean they can incorporate encryption in addition, right? I mean it's a customization.
It depends on the vendor actually.
Vendor.
So I've seen Philips do this. Like these guys, Philips had a really good response team. So if you found a bug with the systems, they made sure it's fixed, or they'll give you a fix for this.
So one last question. So how did you get into the networks? Is it through?
Oh, it's really easy.
Okay.
So one of the ways, is the camera off? Okay, can you turn off the camera?
You mentioned about DICOM and PACS. I was just
Yes.
wondering, is DICOM standard also has similar challenges in terms of?
No, DICOM is technically really different from HL7. So I feel DICOM is much more secure because they had encryption. They were talking of encryption and these standards and protecting this from a long time ago. There is some really good research and they've published on Black Hat channels. I would highly recommend to see that. Someone has actually broken into DICOM encryption systems, but still they're doing a really good job in securing PACS and DICOMs.
Okay, thank you
Thank you.
for the great talk. I mean, very complicated and lot to learn.